Hello guys, welcome to my channel. In one of the first tutorials, I show you how to create some powerful Eurostat maps. But in the meantime, Eurostat has changed its API. Luckily for us, there is a new R package that deals with this. So in this tutorial, I will show you how you can once again access this powerful data set and create some awesome Eurostat maps. Our first step is to install and then load the packages that we need. The first one that we need is a REST API, and this one we need to install from the development version on GitHub. So for that purpose, we need to first of all make sure that we have a package which is called remotes. So that's why I'm here. I'm first installing that one. And then from remotes, we need to call a function which is called install GitHub. So this function is going to help us install from the GitHub repo, and the name of the GitHub repo is Eurostat/REST API. All right, once we have this, we're ready to install and then load other packages. I'm going to here define a list of libraries that we need. And the first one that we will, of course, we will install by running this is this one, but we also need to load it later on. So I'm going to add it to the list. Then the next one is Tidyverse, which is the umbrella package for data wrangling and data visualization. From this one, we'll be using ggplot2 for data visualization and dplyr and tidyr for data wrangling. The next one is gsco.r, which is going to help us get country boundaries for European countries. Then the next one, to work with these boundaries, we need an asset package because gsco.r returns in the simple features or asset format. And last but not least, we'll be using class_in package for creating our breaks. Now that we have this, we need to first of all check if these packages are installed. So I'm going to use here this list libs, and I'm going to go into the row names of already installed packages. And then we need to actually check if these are installed or not. So here we need to write an if-else statement. So if any of these installed libs equals false, in other words, if they are not installed on our system, then we here open this curly brackets, and then we say to R here install packages. But we don't need all of the packages to be installed. We need those from the libs that are not among the installed libs. And then the last thing here is to also install all the dependencies of these packages. The final step here is to load these libraries that we installed, which is quite easy in R, given that we have the list of libraries. We simply need to provide here the list of libraries, and then we need to also write here the function which is called a library, and it's used for loading packages in R. We'll need two sets of boundaries. The first one is the nuts, so regional boundaries, and the second one is a country boundaries, which is going to serve as an overlay on our map. Let's first of all fetch the nuts boundary. So there are two types of nuts boundaries that we use here. This is nuts2 and nuts3. So nuts3 is more granular level compared to nuts2, and in this case we'll be using nuts3. So we first of all need to define here nuts3 sf, and then we'll be using gsco.r to fetch. So there is a function in gsco.r which is gsco get nuts. Sounds crazy. So here you need to specify at least two things. So the first one is the nuts level that you want to fetch. So here it's 3, but if you're fetching level 2, you should put here 2. The second one is the resolution. So it goes from 1 to 20. And here we're going to go for 3, which is not completely crisp, but it's still in a good shape. And then last but not least, you should also here choose the year of the nuts. So the default one is 2016, but because our data is from 2022, it's not going to map well to the data points. So we're going to use the latest one, which is 2021. The second object we need here is the countries boundaries, and I'm going to create here object countries sf, and again I'm going to call gsco.r, but this time a function which is called gsco get countries. Sorry, not coastal lines, but countries. So over here we again can specify this resolution, which is 3, and then because we will also encompass some of the countries from Asia, such as, for example, Cyprus, Armenia, Azerbaijan in our map, we want actually here to get for the region both Europe and Asia. So I'm here going to specify in this list Asia and Europe as regions. For some countries, there is no Eurostat data, either because they don't have a data sharing contract with Eurostat, or maybe in this specific case, they do not share the data with this organization. And this needs to be reflected on our map. So for those countries where data is missing, we would like to color them in gray. But to do that, we also need to single them out. Basically, in this part, what we will be doing is we will be creating two groups. One group for which there is the data, and the other group of countries for which there is no data for any specific reason. So we will actually create two lists. The first one is going to be for those that do not have the Eurostat data in this specific case, and I'm going to call this non-EU list. And then I'm going to actually spell them out. So Armenia, which is AM, Azerbaijan, AZ, and then BA, which stands for Bosnia. So again, some of them don't even have a data sharing contract with Eurostat, others do not share or did not share in this specific case. Then Belarus, then Georgia, then Moldova, Russia, Ukraine, and then the last one is a specific case, which is the case of Kosovo, which sometimes shares information with Eurostat and sometimes doesn't. In this case, it doesn't, and there is additional complexity, which is the Eurostat country boundaries puts Kosovo together with Serbia, so as a single country, and we also need to account for this. But for now, we will just put this as a list of countries and regions that do not have information, Eurostat information. All right, the next thing is to then enlist the countries that will have information. So over here, what we're going to do is we're going to simply take the unique NUTS ID or country codes from this object that we previously created, which is nuts3_sf. So what we're going to do here is we're simply going to take country_codes column and then unique values from it. Okay, now that we have the list of countries that have Eurostat data and the list of countries that are not covered, we need to actually create now two simple features objects. So we're going to be doing that simply by filtering based on these two lists. So let's first of all do the countries that have. Here we can just use this countries SF object, and then we can put it into a pipe, and then using dplyr and filter, we can filter. So we filter actually this country ID. And over here, what we do is simply use in function from base R, and we use, of course, this EU list that we previously created. The same thing we can do for the countries that are not covered, which are called here non-EU_SF. So over here, we simply need to use, instead of EU list, this non-EU list. We're back at the Eurostat database website where you can search different data sets either on the NUTS or the country level. So in this tutorial, we'll be working with NUTS datasets. So in order to access them, you need to navigate here to the regional statistics by NUTS classification and then expand by clicking on this plus sign. Over here, you will be offered several areas. And in today's tutorial, we'll be working on the median age. So we need to click on regional demographic statistics and expand also that folder. And then once more, click on the population and area folder and expand it. Over here, you will find quite a lot of different data sets on population, but what we need is the one that has population structure indicators by NUTS3 region. If you're, however, interested in making this map on NUTS2, you simply need to take this one, which is population structure indicators by NUTS2 region. But we'll be using this one, which has the code demo_R_PJNIND3. And it would be really actually a good thing to right now copy this code of this dataset, because back in R we'll be using it to access the data. Anyways, you can actually expand by clicking on this table icon here, just on the left-hand side of this title. And this is actually going to lead you to the new link where you will be able to see the details of this dataset. Now, the best way to explore this dataset is to search for this plus here sign, which is gonna lead you actually to your dataset, the dataset itself. So in R, if you're working with these Eurostat datasets, you should actually look at the codes that they, the codes that are used for naming them. And here we'll be working, as I said, with the median age of population. So we need actually only this one. And it would be also good to actually copy the name of this indicator because we'll be using it also back in R to call it. So this one. Now we can also scroll here. You also have here NUTS ID. So these are the codes for the different regions. There is also time. We'll be taking values 2021 and 2022 because not all 2022 values are there, as you will see later on. Time frequency is not important because this is annual data. So anyways, we only have 4 specific years. And the final one is the measure. So now, because we're working here with median age, we will need to specify the year as our main measure. All right, so we can simply go back now to the table itself. And over here, you will see that there is data for 2022. This is the freshest one, but you will also notice that there are also some gaps in this data. And in order to, of course, account for the gap in the data, like for example here, what we will do back in R is simply we'll be copying and pasting this 2021 data for 2022. This is how we will make sure that we have the complete data. All right, so once again, what we need here is the codes, online code of this data set. So we need to copy this one. And once more, we also need to copy this indicator because we'll be using it back in R to filter the data and only retrieve the median age of population data sets. Now that we have the basic info about our data set, it's time to fetch it through R. So we're going to create here an object called indicator_df. So this is going to be a data frame. And then we're going to call this REST API. And it has a function which is called get Eurostat data. So within this one, there's several things that we need to define. First of all, we need to define the code of our data set. So this is what we previously fetched. And we're just going to paste it here. So this is the code of our data set. So that's the first thing. The second thing, and very exciting that this data set, or this actually package has, is that you can apply filters so that you get only the specific columns and rows that you need. So here I'm going to go for filters. And then within filters, I'm going to paste here the name of the indicator, the code of that indicator, which is this one. And then the second one that I want to specify further is the unit that is used here. So it's used, we used years, which is YR. So that's the second, a very useful argument within this function. Then the third argument is date filter. So over here, what you can do is you can specify dates, if dates are available in your data set, or years, like in our case. So if you're specifying dates, you need to wrap them into this double quotation marks. But if you're using years like we are using, because this data set supports only years, then we can simply use numeric format. Now, a good thing about this package is that it allows you to fetch not just one, but more years. And in our case, we would like to get the data for 21 and 22 because not all countries and regions have the data for 22. So what we can do here is we can provide a list, and then within this list, simply say we want data from 21 with 22 inclusive. All right. Then there are two more arguments here that you can use. The first one is exact match. So yes, in terms of the filters, we want the exact match for these indicators, but maybe sometimes if you want to grab more data which has similar indicator names, you maybe want to put this here, exact match equals false. And then the final one is a label. Well, actually, I would like to receive codes because it's going to be much easier to filter than if you have labels. So I'm actually putting here label equals false, which means simply that I'm going to simply get codes here. All right, so you can actually then run this one, and this is going to communicate now with this Eurostat API. And it's going to fetch the data in the data frame format. So now we can actually inspect the first few rows just to see if this actually got the data that we need. So I'm just going to pass here this indicator df, and then I'm going to just, increase this one. And as you can see, we have the data from the Eurostat. We have geo, which is the identifier for the nuts region, we have a unit here, year, we have the indicator, which is median age of the population, time. You can only see here 2021, but there is also 2022. And finally, values denotes here the year, so the median age. We only need 3 columns from the table. So in this step, we're gonna filter our table. We need column number 1, which is the nuts ID. We need column number 4, which is the year. And then we need column number 5, which is the age. So here I'm going to create a new object, a new data frame, which is going to be filtered. So I'm going to call it also filtered here. And then we're going to use the one that we previously created, which is indicator_df, put it here into a pipe. And then from dplyr, we use select, and we select, as we said, 1, 4, and 5. And then in the last step, I would like to rename the first one, which is called currently geo, because in the shapefile, it's called nuts ID. So we can use from dplyr a function called rename. And here we first put the new name that we want to use. And we put here also equals to the old name, which in this case is geo. And then when we actually run this, and when we inspect the first few rows of this indicator, actually it's indicator filtered df, you will be able to see now only those that we selected. So nuts ID, time or year, and finally also values. So you remember that I said that some regions lack information on median age for 2022, and we would like to replace those with information for 2021. Where to do that, we first need to actually convert this data frame from a long format into a wide format, in which each of the years is going to be one of the columns, and then rows are going to be the age values for that column. So let's actually do that. We're going to create here something which is called indicator wide_df, and then we're going to use indicator filtered df, which we previously created. And here is where we're going to be using tidyr, which has a function which is called pivot wider. So within this one, we need to actually do 2 things. First of all, we need to say here what are the names that we're going to be getting this from. So what are the rows? So the name is time, which denotes those years. So this is going to be then used to create those 2 columns. And then the second one, what are the values that we're going to be getting them from? And we are going to be getting them from the column which is called values. All right, so we can now actually run this thingy. And then once we run this, we can also inspect the first few rows so that you can see actually what we created here. So this is what we created in this case. As you can see, now we have 3 columns in total. So we have the nuts ID column, we have the column which is called 2021. So this denotes 2021 year. And then we have 2022. And you can immediately notice here that, for example, for Albania, data is still missing for some regions for 2022. So what we're going to be simply doing here, copying these rows for 2021, which are not available in 2022, into the 2022 column. Okay, and then the final step is to simply replace the values in the 2022 column with values from the 2021 column. So here is what we're going to do here. We're going to create a final object, which is going to be called indicator df final. And then in this one, we'll be passing this indicator wide df into a pipe here. And then from dplyr, we'll be using here mutate because we want to change the values column. So what we'll be doing here is simply we're going to be creating the new column which is called values, and this column is going to be conditionally created. So it's going to be created using if-else function from dplyr here. So the first thing here is if this first column, if 2022 column is NA, so if the data is missing, then the second thing is use the 2021 column. And then finally, if the data for 2022 is present, then simply return the data for 2022. This is very, very simple. And then the final step in this section is simply to just select nuts ID and values now that we replaced the values. So we can use, again, select from dplyr and use nuts ID here and also values. All right, and then we can simply run this chunk. And once we run this chunk, we can also again explore so that you can see what's going on here. So the object is indicator df final. And let me just pull this up so that you can see. So now what you can see here is for Albania, those 5 values, we now copy them and paste it here from 2021, and we got rid of the year column. We don't need it anymore. And now we finally have the nuts ID and the values column. The nuts ID column is gonna be used to merge it back to the nuts3 shapefile. All right, and then the final step is simply to merge the nuts3 shapefile with the data frame. So here we can create a mapping SF object, for example. We can call it that way. Then we can use this nuts3 SF. We put it into a pipe, and then from dplyr we can use a left join where the nuts3 shapefile is going to be on the left hand side. And over here what we pass is this indicator df final. And then the column which we're going to be using to join these two is nuts ID, which is present in both the data frame and the SF object. And finally, we can also run this and then inspect. What you will see now once we inspect the first few rows is that there is also now the geometry field, which is always present in shapefiles, and also additional information here about the bounding box, about the coordinates reference system, and of course all the columns from that nuts3 shapefile are now also here together with our values column. In this section we will be defining 3 things before we go and create our map. The first one is to define the breaks. The second one is to define the colors, and finally the bounding box of Europe. Let's start off with defining breaks. For breaks, we'll be using class in package, which we loaded at the very beginning, because this one allows us to define natural intervals. And for this purpose, we can use class intervals function here. The first thing that we need to do though is to call the column that we want to, of course, to which we want to apply these breaks, and that one is values from that mapping SF that we previously created. So that's the first one. Second one is the number of breaks. Here I'm going to go for example, 6 breaks. And the final one is the style. So if you're going to go for the style, you can choose a lot of different things. And those are, for example, a quantile, the equal one, or janks, so different breaks. I'm going to go for the equal because I would like the legend to be equally spaced. So that's the first thing. And here we also need to capture this component breaks, which exist in this ni object. So that's the first thing. The second thing is to append the values here, where we want to append the minimum and maximum values so that we really make sure that our legend has minimum, maximum values, and everything in between defined by this equal style. So to do that, this is what we are going to do. First of all, we're going to create an object break, and then we're going to put this one into a pipe. And then what we're going to do is append here. So we're going to append here the maximum value from this values column. And then what we're going to do after doing this append, we're simply going here to delete the first, or that is actually the last value. So we're going to delete the last value here. And then the second step is to add also to the final object, which we're going to call breaks, to add the minimum value. And then we have minimum, maximum value, and then we also have those 4 values that are equally spaced. So here we simply need to create a list, and this list is going to have the minimum value from this mapping SF object. And then it's going to have also these breaks here. So it's basically going to put this minimum value at the beginning of the list. But we also need to make sure that we delete the last value, which is not needed. So simply using this tail. For colors, we'll be using Viridis palette, using hcl.colors from base R. And to get the colors, what we will do is actually, first of all, check using this previous code, check simply, okay, how many of these actually breaks we have. So let's actually run this quickly. And then let's determine the number of breaks by simply accessing this object breaks. So here you can see that there are actually 7 breaks, and we need to account, of course, for that in terms of the colors. So for colors, I'm going to create object called colors, and then from base R, I'm going to call this function hcl.colors. So over here, we're going to say we have 7 values, and then here for the palettes, we're going to be calling a viridis palette, which has a really nice mix of yellow, green, blue, and also purple. And then the final thing here is we're going to use a reverse palette here, which means that lighter colors are going to be associated with smaller values, and darker colors are going to be associated with higher values. One final step before mapping is to define the bounding box, which is going to help us limit our view only to Europe and only to the data points. Currently, we actually have the countries and country boundaries that also encompass the entirety of Russia, which we currently don't need. So this is going to help us cut off those parts that we don't need and focus our attention only on the parts that have the Eurostat data. So the first thing before we jump to creating a bounding box is here to define the coordinates reference system that we'll be using. And this is the Lambert conical projection, which we use also in previous many tutorials where I work with European countries. So here we will simply define this as CRS Lambert, and then we're gonna put here double quotation marks around this coordinates reference system so that it can be consumed within R. In the second step, we need to create a bounding box. For any bounding box, you need 4 values. You need minimum and maximum, a longitude and a latitude values. Now, what I wanted to do here is I wanted to encompass area from Iceland in the west to Turkey in the east, and then from Cyprus in the south to Norway in the north. So I simply went online and to a bbox finder website, which I usually use for creating these bounding boxes, and then over there I simply drew a rectangle with this in mind, which gave me values for the latitude and longitude. So these are the values that we'll be using. So this is the minimum longitude value, which is the westernmost part. So it's going to be minus 10.66. The second one is the minimum latitude value, and this one is going to be the southernmost part, and this is 34.5 degrees. The next one is X maximum, which is the easternmost part, and this one, the value for this one is going to be 45 degrees. And finally, the northernmost part of the map, denoted here by Ymax, meaning maximum latitude value, is going to be 71 degrees. One thing to remember is these are the degrees in WGS84 coordinates reference system, which we will need to define once we use these components to build the bounding box. Now, building the bounding box here, we're going to name it bbox. And then to create the bounding box, we need to first of all declare it using SF package as a list of spatial objects. So over here, we're using this function, and then this list is actually going to be composed of polygon. So this is going to be a polygon. Now, our polygon here is going to be the list of values that we're going to be putting together. And there are actually 2 groups of values. So there are longitude values denoted here by X, and latitude values denoted here by Ymin and Ymax. So we're going to start off with the longitude values. Over here, you need to pass 5 values. So you need to pass minimum longitude value, and then you need to pass maximum longitude value, followed by another maximum longitude value. And then the last 2 should be both minimum longitude values. So this is gonna enclose the polygon, at least when it comes to from the longitude side. So that's the first part, that's the first member of this list. The second one, as we said, is these latitude values. So over here, you need to pass, first of all, Ymin, followed by Ymin. And then you need to have 2 values of Ymax. And then finally, you enclose everything with a Ymin. All in all, you need to have 5 members of the list here. And also here, you need to have 5 members of the list. They need to be in this order, but this is not all, because R, if we actually run this, R is not going to understand what is the coordinates reference system. So over here, we need to define it. And as I said before, this is the WGS84 coordinate reference system. So we need to pass here 4326 for R to understand that. So what we essentially here created is a polygon, but we do want to transform this polygon into a Lambert projection. Remember, we said that the entire plot is going to be in this projection. So I'm here going to create an object called a Lambert bbox. And then from SF, I'm going to be using here ST transform. And then I'm simply going to pass here this bbox object. And for the coordinates reference system, I will be passing here this CRS Lambert. And then the last one, for ggplot2 to use a bbox, it should be a bounding box object. So what we're going to do is simply create an object called bb. And then using SF ST bbox, we will simply coerce this polygon into a bounding box, and this bounding box is going to have once more this Lambert projection. And we are finally ready to map. So over here, we're going to start off by calling ggplots and then defining our main data, which is mapping underscore SF. And now we can go ahead and provide the layers. So we're basically going to be working here with SF objects. So we will need here a geom SF attribute or function from ggplot2. The first thing here that we need to deal with is the case of Serbia, where we have actually a country that also encompasses Kosovo inside of it. So here we're going to do a small trick. What we're going to do here is we're going to take only from the list of those countries that have Eurostat data. We're going to use this country underscore ID, and then we're going to grab here Serbia. And what we're going to actually do here is we're gonna fill it with the gray color using gray 80 here, which is for missing values. Of course, the values for Serbia are not missing, but what we're gonna do with this small trick is we're simply gonna paint Kosovo, which is here a part of Serbia, in gray, while keeping Serbia, the rest of Serbia, in color. So this is the small trick. Here, what we're also gonna add is the color of the boundaries, so that's going to be white, and also we're going to define the size of the boundary, which is going to be 0.15, so a bit thinner. Okay, so now that we dealt with this one, we can go ahead and add actually the main layer, which is those nuts regions, and filling those nuts regions with colors. So again, we're using here geom SF, and then for the data here, we are actually going to be using here mapping, and then equals to, and then the main aesthetics. So here, because we want to fill those polygons with values, we are simply using the fill equals to values. That's it. In terms of the color of the nuts borders, I usually choose here not to have them because there's a lot of them. So that's what kind of complicate the map, because we already have the overlay of national boundaries. So I choose this one, and then also for the size of the nuts boundaries, I also choose here that equals 0. Okay, that's almost it. We have 2 more layers here. Remember that we also need to add both the European country boundaries and also those that do not have Eurostat data. So we'll be using GeoSF once more. And then for the data itself, let's first of all add those countries that have the data, their national boundaries. So this would be the EU underscore SF object. So over here, we don't have the main aesthetics anymore, but we do want to color, of course, the country boundaries. For that, we'll be using white here. And then for the size of these boundaries, we can use actually this one, so 0.15 that we used here. And then finally, because we only want the boundaries, we don't want to fill those country polygons with something, we're gonna here for fill define that it's going to be transparent. So this makes sure that the data points for the nuts regions are gonna be shown, but together also with this country boundaries. So this is what we did for those countries that have Eurostat data. And now we will, in the same fashion, also add those countries that don't have. So simply here, we're going to be passing non-EU underscore SF, and everything else is basically the same. So that's the first part where we define the main layers. Then comes the next part, which is customizing the map itself. One of the things here, as we said before, is we need to define a coordinates reference system, and we also need to pass here the bounding box itself. So we need to tell actually ggplot2 that we only want the view to be limited to a certain area. So for that purpose, we need to define here xlim and ylim values. Basically, xlim, these are the values for the longitude, and ylim is for the latitude. And these need to be passed, of course, as a list. So here we have two members of the list. We have the minimum and maximum longitude values, and then over here we have the minimum and maximum latitude values. Now they're both coming from that object BP, which is converted into the Lambert projection. So basically what we're doing here is simply saying, yeah, grab the minimum longitude value here from this BP object, and then also grab the maximum longitude value from this object. Okay, so this is the first part. So for the ylim, we'll be using basically the same thing. So what we need to do here is simply replace here xmin with ymin and xmax with ymax. And that's basically it. We can then go ahead and customize the color. We are here using continuous value. So we also need to use from ggplot2 a function that is gonna reflect on that. So this is scale field gradient, which is exactly going to deal with that. Over here, we can define several things. The first one is if we want to have the legend title, and we do want, so we can say here median age and maybe in the brackets years so that people know what is the main measure. The second one is the colors. So for the colors, we already have that list of colors, which is called calls. The third one is breaks, and breaks we already have, they're called breaks. And then we have labels. Now for the labels, you probably noticed that we have decimal values, but I'm not happy with this decimal value, so I want to round the values, and we can use a round from base R and simply round breaks to 0 decimal places. The final thing that we can do here is define the limits of our plot. So this is actually a list of minimum values from, of course, our main data set, which is called mapping SF, and the values column, and the second one, which is the maximum value. So I'm putting here limits to make sure that we encompass all the values, but they're also included in the legend. All right, and then in case there are some NA values, you can also define them here. So the color for the missing values in this tutorial is this gray 80, which is light gray, and we're using it throughout also this code. Now that we defined the colors, we can also define the legend, how the legend is going to look like, and for that purpose we can use guides. Our main aesthetic is fill, so we need to define this here, and then for the guide we're using here guide color bar because our values are continuous. So over here we can define several things. The first one is the direction of our legend. I would like our legend to be horizontal, so that's why I'm putting it here. You can also define here the bar height and the bar width. So the bar height is going to be a bit thinner, so let's say 2.5, and then in terms of the units we can actually use here millimeters. So I can just put the units equals to millimeters, and we can actually do the same for the bar width. So I'm just gonna basically copy this one here. So I'm gonna define here bar width, and then bar width should be actually longer, and I'm gonna put here 50 millimeters, which is basically 5 centimeters. So there are some other things that you can define in terms of the legend, and one of them is the title position. Since we have a title, I would like the title to be on the top. That's one thing, and there are other things that you can define about a title. So one of them is, for example, the horizontal justification. I would like it to be in the middle. And what we did here for the title, we can also do for the labels. So we can do label.position here. And for the label position, what we can do is we can have the label to be on the bottom side. So just below the legend itself, and we're doing this because the legend is horizontal. So label position, and we can also use here the horizontal justification for the levels as well, and we can also center them using 0.5. You can also here define the number of rows, which is 1, because our legend is horizontal, and we would also like those legend keys to be next to each other So that's why I'm putting here that by row equals true. All right, one of the last things is to define here the theme of our map, and I like to start off with the theme void, because this theme basically gets rid of any excess elements around your plot. And then I like to follow this one with a theme, because over here I can then define some other things that I could not in this theme void, and one of them is the legend position. So the legend position that really works well for Eurostat maps, I figure out, is something which is on the top of the map, but it's more on the left-hand side. So these are the coordinates, so 0.35 and then followed by 0.95. So the first value here is the x value, so this is how it's gonna, where it's gonna be from left to the right, and this one from the bottom to the top. So legend position is the first thing. We can also specify legend text and legend title. So let's, for example, first of all specify legend title. Legend title is the text. So we need to tell R or ggplot2 actually that here we are dealing with element text. And then only then when we open the brackets, we are able to actually customize here. So for the size of legend, we can, for example, go for 11 pixels. And also for the color of legend, we can, for example, go for, let's say, charcoal gray here. All right, that's the first thing. The second thing, we can also define here the legend text, also size, color. So we can simply copy here and paste and just go for a bit smaller font size. Now, when it comes to legends, sometimes there is a bit of a more spacing for your legend, and you can actually regulate this using a legend.spacing.y. So this is going to regulate it on the y-axis, or basically on the height axis. So here what you can do using this attribute is you can decrease this. All right, so you can, for example, minimize this gap, and let's say we use here 0.25 centimeters for that purpose, but you can definitely play with this and see what really works for you. Okay, related to this one is also title. We would like to have the title here, and we should also define the title. Title, like the legend, is also element text. So we're here dealing with the text, and we can also define several things. So we can also define size the same way we did with the legend. We can go for a bit, a bigger size because we want the title to be visible. We can also make it bold like this, and we can also choose a bit different color. We can choose, for example, either one of the colors from those colors that we have, or we can just go for something like, let's say, gray 40, which is something like a simply gray color. We can also make the title centered using this, and we can also move it a bit up so that it doesn't really interfere with the map itself. Of course, it's a really good idea to add the caption here, where you can, for example, have the references who created the map, if you created the map, and also references to the data, for example. So over here for the caption, we can choose a size of, let's say it's going to be 10, so similar to the legend text. For the color, it can be a bit lighter, so I'm going to here go for, let's say, a light gray, so it's not that completely visible. And then it can also be centered, and in terms of the vertical justification, we can push it up a bit towards the map, so just we make sure that it's not, doesn't end up outside of the margins of the plot. And speaking of the plot margins, we can also define them. This is actually a very good thing to define, because in some instances you want to actually narrow your view further, and this is exactly what we need to do here. We don't need to actually narrow down the top view, but we definitely need to narrow a bit the right hand side view, which is basically the west side. We also need to narrow a bit down the bottom hand side, and finally we also need to narrow a bit down the left hand side, and also using basically the same values here. And finally here we can use lines for that purpose. Okay, so this is how we define the theme itself. It's a bit longer code, but here comes the last part where we also define the labels using the labs argument. So over here you can define, for example, you know, your data. In our case, this is basically a caption, so we can just use caption here. So caption equals 2, and then simply here we can pass, you know, let's say the references here, and we also have the title, so we can also here write a title, which can be, for example, median age in, let's say, 2022. And this is how you create crisp and effective Eurostat maps. In today's tutorial, we created one such map, but I'm really looking forward to your own use cases and how you take this tutorial to some other indicators and create some awesome Eurostat maps. If you're interested in replicating today's analysis, I prepared a link to the GitHub repo in the description box below, so do check it out. Feel free to clone it, modify it, reuse it as you see fit. If you have any questions, comments, or just general feedback, feel free to reach out to me here on YouTube, but also on Instagram and X. If you're new to R and you seek to expand your data visualization and geospatial knowledge with R, I've prepared a few cool tutorials for you, so do check them out. See you next time.